Okay, here's problem number 4 from packet number 5. Let's talk about some really big ideas first. Big idea number one is that for all of these projectile problems, we have a couple of things that we already know. We already know that the acceleration is negative 32. Again, assuming that we're working in the English unit system. If we were working in the metric system, then we'd end up saying negative 9.8 instead. All right. By the way, we also know that the velocity is negative 32t plus initial velocity. That would be as if we took the antiderivative of negative 32, got 32t plus c, and then if we happen to know what the initial velocity, that c ends up being the initial velocity. And then lastly, that the position is negative 32 over 2t squared plus v naught t plus s naught, the initial position. Yeah, I thought I wrote squared.
You did, but
it didn't register. Stupid new technology. All right, now we know all of this, but let's hone in on what is it they're asking us about this particular problem. The average velocity. The average velocity. Not the instantaneous velocity like we have with the VT formula, but rather the average velocity. The average velocity is going to be found by taking two values of velocity. Right. We have two ways to do this. There's two ways to do this. One of them is going to be using the average formula. Excuse me, I have to switch over to, I gotta erase what I wrote. Erase, no, I don't want pen. What? Eraser. Okay. Pen. Okay, so one way is to use the average velocity formula. And our average formula, in fact, I think this is maybe the only way to do this. All right? And that is to say, okay, the average of this function over this time span. What is our time span? During the first 2 seconds. Okay, so this is going to be the integral. That is really weird. I'm not touching it. No, it's like having sticky stuff on your fingers and I can't get it off. Okay.
What is it via t?
Okay, let's see if I can erase that. All right.
You take the integral of a of t to get the velocity.
Right.
But for average.
But I want the average velocity, and this is just our general. I mean, replace v with f, and that's essentially our average velocity formula.
It's displacement over time.
All right. So in this case, the integral from 0 to 2, and of course it's going to be 2 minus 0 out in front. And what do we know? Well, we know our velocity equation is negative 32t plus. Now, are we said anything about the initial velocity? Oh, it's 96.
Oh my god.
This is not a good start with this technology. What problem are we on? 4? Okay. Let's try this again. All right. So there's the integral expression that we're going to want to find the value of. So 1/2 antiderivative of negative 32t is negative 16t squared. Antiderivative of 96 is 96t. And we're going to evaluate this from 0 to 2. So this is going to be 1/2. If we plug it in on our upper bound, 2 squared is 4. 4 times 16 is net, and as a negative, so it's negative 64 plus 92. And then minus, when we plug in the 0, that's 0. Alright, so what do we end up with? 192 minus 64, I have no idea what that is off the top of my head. Indeed, 128. So it's 128 divided by 2. So 64 in our units is feet per second. So I say the answer is C. Is that the answer, right answer according to our answer guide? Okay, great. All right,